Today's my lecture is about sampling design used in research. Sampling is the act or process or techniques of selecting a suitable sample or a representative part of a population for the purpose of determining parameters or characteristics of the whole population. Sampling is used to obtain information from a representative sample of the target population. It is essential that number of individuals participating in the survey be large enough to produce results that are reliable and valid and truly represent the target population. A sample is a finite part of a population whose properties are studied to gain information about the whole. A population is the entire set or group of individuals, objects or items of interest having some common characteristics from which samples are taken. The purpose of sampling is to draw a conclusion about population from sample. A sample deals with only a part of the population and cannot perfectly represent the population. This results in an error or discrepancy which is known as sampling error. Sampling error comprises the difference between the sample and the population that are due solely to the particular units that happens to have been selected. The basic causes for sampling error are chance factor operating on the process of a sample selection, sampling bias as a result of poor sampling plan. Sources of sampling error are inadequate sample size. The smaller the sample, the more difficult it will be for the sample to truly capture the characteristics of the population. The larger the sample, the better, but collecting large samples cost money and resources. Sampling error are negative if the parameter is underestimated and positive if it is overestimated, and it can be reduced by increasing the size of the sample. The error that occurs at the stage of gathering and processing of data are known as non-sampling error. It includes faulty sampling frame, biased method of selection of unit, faulty interviewing, incomplete or inadequate responses, error of observation and measurement, processing errors such as error in editing, coding, and etc. These errors can be controlled if the volume of data processed is small. Sampling bias refers to the overall tendency to favor the selection of units that have particular characteristics. It arises from the selection of a sample that is not a representative of the population from which it was drawn. The sources of sampling bias are deliberate selection, substitution, incomplete coverage, haphazard selection, inadequate interviewing. Stages in the selection of a sample includes defining the target population. A population can be defined as target population, which includes all people or items with the characteristics one wishes to understand. Complete set of individuals from which information is collected. And the second step is selecting sampling units and sampling frame. Sampling units are the part of the population from which samples are drawn. These units make up the whole population. Every element in the population belongs to one and only one unit. Sampling frame is a list of sampling units. And the third step is selecting or planning sample design. A sample design is a definite plan concerned with all principal steps taken in the selection of a sample and estimation procedure. A sample design can be described by two factors. Sampling method. Sampling method refers to the rules and procedure by which some elements of the population are included in the sample. Estimator. The estimation process for calculating sample statistics is called the estimator. Different sampling methods may use different estimators. Now comes the selection of sampling methods. Sampling methods are procedure for selecting sample from a given population. A sampling method is specified before any data are collected. And there are probability and non-probability sampling methods. Probability sampling is used when selection of sample from a population is based on chance. Every element of the population has known probability of being selected for the sample. And non-probability sampling is used when selection of sample from a population is based on judgment. The element of population are arbitrarily selected for the sample. A non-probability sampling method include convenience sampling, purposes sampling, and snowball sampling. While the probability sampling method used are simple random sampling, systematic random sampling, stratified random sampling, cluster sampling, multi-stage random sampling. Convenience sampling is obtaining a sample of people or units that are most convenient or easy to reach. It is useful for exploratory research and case study research. Purposes sampling is done for particular purpose, and there are two major types, judgment sampling and quota sampling. A judgment sampling is selecting a sample based on judgment of an individual about some appropriate characteristic required from the sample member, and it is useful in the early stages of an exploratory study. A quota sampling is selecting a sample based on quotas about certain relevant characteristics describe the dimension of the population. A snowball sampling is selecting a sample depend upon current participant recruiting other potential participants into the study, and it is used when participants with specific characteristics are difficult to allocate. Simple random sampling, a simple random sampling that ensures that each element in the population has an equal chance of being included in the sample. How to choose random sample? Assign each element within the sampling frame a unique number 1 to n. Identify a random start from the random number table. Determine how the digits in the random number table will be assigned to the sampling frame. Select the sample elements from the sampling frame. Systematic random sampling, a sampling procedure in which random starting point is selected and the sample is selected by taking every kth element in the population after the elements of the population are arranged in some way. How to choose systematic random sample? Identify the total number of elements in the population. Number the n elements in population 1 to n in some order. Select a sample of n size. Identify the sampling ratio. Identify the random start. Draw a sample by choosing every kth element. Stratified random sampling, a sampling procedure in which a population is divided into subgroups called strata, and a sample is randomly selected from each stratum. Age, social economic divisions, nationality, religion, uh, educational achievement, and other such classification falls under stratified random sampling. Good stratification required that each strata should be internally homogeneous, but externally the strata should be different from one another, that is heterogeneous. The strata obtained by subdividing the heterogeneous population into homogeneous groups adequately represent the population as information concerning individual stratum is gathered. How to choose a stratified random sample to determine sample size needed for subgroups? Obtain list of each subgroup. Use either simple random or systematic sampling to select sample from each subgroup. The overall sample is obtained by combining the sample for all strata. And there are two types of stratified random sampling: proportionate stratified random sampling, disproportionate stratified random sampling. In proportionate stratified random sampling, the elements in a sample are allocated among the strata in proportion to the relative elements in each stratum in the population. Each stratum sample size is directly proportional to the population size of the entire population of the strata. That is, the sampling fraction is the same in all strata. The disproportionate stratified random sampling stratification departs from the proportionate relationship. In a disproportionate sampling, each stratum will have a different sampling fraction. Cluster sampling, a sampling procedure in which a population is divided into groups called clusters. Clusters are then randomly selected and a sample is collected by randomly selecting from each clusters. Cluster sampling requires that clusters should be as internally dissimilar as possible and different clusters should be very similar. There are two types of cluster sampling: single stage cluster sampling and multi-stage cluster sampling. Now comes to the multi-stage sampling. With multi-stage sampling, one select a sample by using combination of different sampling methods. For example, in stage 1, one might use cluster sampling to choose clusters from a population. Then in stage 2, all might use simple random sampling to select a subset of elements from each chosen cluster for the final sample.